All right, guys, here we go. Lesson 822 for geometry. Again, for today, make sure you guys have your books open to 822 and make sure you have these notes out. Okay, have those two things. All right, so you have your books open. Get to number 78 here. I want you guys to work through this one. So read through this one. This one's kind of the real life relationship. So read through it and answer A through C. Okay, get all those done before you start this back up. I'm guessing it'll take around 8 minutes. Okay, so pause this video, take 8 minutes, and work through these problems. All right, so now that you've gone through it, let's go ahead and answer these questions. So first thing, we had a 4x5 photo that cost 45 cents. Okay, and so Alice went to the print shop and she was trying to pick out which size she should pick. And hopefully it was kind of clear that we should pick the 8x10 inch one. Okay, because when we scale up our photo, we don't want to crop it the wrong way. So if we chose the 7x9, those aren't multiples of 4 and 5. So we would be increasing it disproportionately. Okay, and then 10x12, same thing. We want our length, let's say this, or this is the height maybe, okay? The height goes with the height here, okay? And that's not proportionate to the length and length here. It wouldn't be the same scale factor. 10 divided by 4 is not the same as 12 divided by 5, okay? But if you look at this one, 8 divided by 4 is 2, 10 divided by 5 is 2, so that's your scale factor, okay? So you could say it is similar or is proportional with a scale factor of 2. I'm just going to write scale factor and you want scale factor 2 for both length and width. Okay, scale factor of 2 for both length and width. All right, letter B was saying since the cost of the paper was 45 cents, how much should the enlarged photo cost? Well, since our scale factor is 2 here, okay, we need to think about our area ratio, right? Because you're paying for the size, you're not just paying for the dimensions, right? So scale factor is 2, but our area ratio, if you remember from yesterday, going from a scale factor to an area ratio, you have to square it. So 2 squared, which is 4. 2 squared equals 4. So let's write that up at the top of your paper here. Just remember, going from a scale factor, let's say our scale factors are, then our area ratio would be r squared. Okay, going from one area of the similar shape to another, you have to take your scale factor squared. Okay, and that's your ratio. Okay, so it's 4. So now we want to take 4 times that 45 cents. And if you take 4 times 45 cents, that's going to give you $1.80 is how much this photo should cost. So $1.80. There you go. Okay, now it said, let's see, the photo cost $7.20 that the vice principal bought. He just went out and bought one because he wanted to do it. Okay, what are the dimensions of his photo? So if it was $7.20, well, let's divide $7.20 divided by original price of 45 cents. So $7.20 divided by 45, that gives us 16. So that's the area ratio of the principal's photo compared to the original photo is 16. So if we want to go backwards, we have to take the square root. So area ratio was 16. That means our scale factor is the square root of 16, which is going to be 4. So our scale factor was 4. So now if we think about the dimensions of this new photo, we have to multiply these dimensions by 4. So if we have a 4-inch by 5-inch, and we take that times a scale factor of 4, okay, 4 times 4 inches is 16 inches, and then 5 times 4 is, that would be 20. Okay, so the actual dimensions of this photo are 16 by 20, since our scale factor was 4. Okay, a couple steps going on that one. That one's kind of a fun one. You have to think about the price, getting your scale factor or your area ratio, then going from area ratio to scale factor, and then going back to your dimensions of the bigger photo. Okay, 16 by 20. All right. Okay, moving on to number 79. These problems, we're going to make a table of everything we know about these shapes, because the whole point of this second lesson is we're still looking at ratios of similarity between similar shapes. So we're looking at the scale factor, we're looking at the perimeter ratio today, and the area ratio. So all those things combined. Okay. So again, when it says zoom factor, that's the same thing as scale factor. So let's just go through letter A together here. And let's fill out this table. So first of all, the zoom factor, the scale factor. If we look at we're going to put the large figure on top and the smaller figure on the bottom. So if we look at two sides that correspond to each other, I can see that the 15 and the 25 are our lengths. Those are going to correspond. So I'm going to make a fraction here and find that scale factor. So I'm going to do 25 over 15. Always put the bigger number on top. And if we reduce that, these are both divisible by 5. You can do that without a calculator. 25 divided by 5 is 5. 15 divided by 5 is 3. So that is our scale factor, is 5/3. And now we're going to compare that with our scale factor of our perimeters and our scale factor of our areas, or the area ratio. Okay, so if we look at our perimeters, let's figure out our perimeters here. If this is 15 and 6, this is 25, let's figure out what that missing side would be using our scale factor. Well, if we take 6 times 5/3, well, 6 divided by 3 is 2. 2 times 5, this would be 10. Or you can just type that in your calculator, okay, and find that that's 10. All right. I actually want you guys to finish the rest of this table. So go ahead and pause the video here and take, let's say, 2 minutes. Okay, should not take too long. Find the perimeters of each. Make a fraction, same thing that we did here, and reduce it. So see what your zoom factor is. Then find the areas. Area of a rectangle, remember, is base times height. Just multiply them. Okay, then make a fraction with the areas, and then compare our 3 fractions. Okay, so take maybe 2 minutes, maybe 3 minutes. Okay. All right, here we go. So for our perimeters, for the small one, you should have 15 plus 15 is 30, and 6 plus 6 is 12. 30 plus 12 is 42 is our perimeter. If you wanted to, you can show your work off to the side somewhere if you wanted to show that. And then perimeter for the big one over here, 25 plus 25 is 50. 50 plus 10 is 60. Plus another 10 is 70. So that's our perimeters. So if you put that in a fraction, we have 70 over 42. Those are both divisible by 7. Actually, you can divide both those by 14 even. Divide those by 14. 70 divided by 14 is 5. And 42 divided by 14 is 3. So notice you get 5/3. And if we compare our scale factor to our scale factor of our perimeters, it is the same. Okay, now let's see the area. We know what our scale factor should be. It should be our scale factor squared for our area ratio. So our prediction we could have made is that it is 25 over 9 if we square 5/3. 5 squared is 25, 3 squared is 9. So this should be our answer. Let's see if it's right. So the area of this small one, 6 times 15 is 90. And the area of the big one, 25 times 10 is 250. And if we divide those, 25 divided by 90, that does reduce nicely. Divide top and bottom by 10, and you get 25/9. Okay, so there you go. Notice your scale factor of your perimeters is the same as your scale factor, and the scale factor of your area areas is the scale factor squared. Okay. All right, let's try another one. Okay, I want you guys to fill this one out all by yourselves. Okay, and then we'll go through it. So take a few minutes here, maybe 5 to 8 minutes. Okay, pause the video, fill out that whole table, work with your team. Go. All right, so for this one, we had to use our special right triangle. So if you needed a hint on that, you need to use your special right triangle. So since this is a right triangle and it's a 60-degree angle there, this has to be 30. Same with that one there. That's how we know they're similar. Okay. And remember, across from your 60-degree angle, that's a 1:2 ratio, so I know that's 12. And I know across from our 60 here, that's got to be 2. Okay, dividing by 2. And then you can just kind of fill out the rest of this. This has to be 2 squared root 3, and this one over here has to be 6 squared root 3 using those special right triangles. Okay, if I draw that off to the side there, just to remind you guys. Okay, do not forget this stuff. We've got 30, 60, 90. You've got x squared root 3, and 2x. So you guys can just set up your equation to find x and then just fill out the rest of your shape. Just don't forget how to use that, okay? All right, so our zoom factor. If we compare here, we've got 6 and 2. Those two sides go together because they're opposite of the 30. So if we take 6 divided by 2, that gives us 3 is our scale factor, or 3/1 if you wanted to write it as a fraction. Okay, so 3. Now if we look at our perimeters, if you add these up in your calculator, you can just kind of add those up. Let's just go ahead and do that real quick. So if you do 6, 12, and 6 squared root 3. So I'm going to do the 6 squared root 3 first. So I'm going to type in my calculator 6. Let's actually do the square root of 3 first. Square root of 3 is that. I want to take that times 6. Okay, so that's 6 square root 3 right there. It's around 10.4. And then we want to add 6. And then we want to add 12 as well. Okay, there's our perimeter. So it's around 28.4. Oops, sorry, that was the bigger one. So we should put that on the top. So 28.4-ish, approximately. Okay, now if we do the small one, whoops. So 2 square root 3. So if I do the square root of 3 again, is that times 2. Okay, now I want to add my other two sides. So 2 plus 4 is 6, so I want to add another 6. There's my smaller one, so it's around 9.5 approximately. Okay, so now let's find the ratio there. So if we do 28.4 divided by 9.5, let's just do that. 28.4 divided by 9.5. You see we end up getting around 2.989. So this is very close to 3, which if we didn't round here, you would get exactly 3. So you get 3. You can just write 3 there. All right, and then for our areas, remember area of a triangle is 1/2 base times height. So if we do that, I'm going to show my work up here. So area of the small one, let's do the small one first. Area is 1/2 of 2 times 2 square root 3. Half of 2 is 1, so the answer there is 2 square root 3. I'm just going to leave my answer just like this. Okay, 2 square root 3 there. And then if we look at the area of the larger one. That's going to be 1/2 base times height. So 1/2 of 6 times our height, 6 square root 3. Half of 6 is 3. 3 times 6 is 18, so we get 18 square root 3. Again, I would just leave your answer in radical form, or in square root form. Okay, so we've got 18 square root 3 and 2 square root 3. Let's find our zoom factor of the areas, or our scale factor. Okay, in this case, the square root 3's cancel out, and 18 divided by 2 is 9. Which makes sense because if we look at our scale factor as 3, if we take 3 squared, we get 9. So hopefully you're seeing a pattern here. Our perimeter scale factor is the same as our original scale factor, which is going to be super helpful to us. And we already knew the scale factor, or our area ratio, is our scale factor squared. And that's proving to be consistent. 3 squared is 9. So it works out. All right, flip it over. All right, you guys got one more of these, okay? Take another 8 minutes or so, okay? Pause the video, fill out this table, and then when that's all filled out, you can resume the video. All right, here we go on this one. Let's find our scale factor. So first of all, I'm looking at two sides that match up, that are proportional. So we got 40 and 5 that go together. So 40 divided by 5, our scale factor is going to be 8 for this problem. All right, so using that scale factor, we can find the rest of the numbers here. And looking at this problem here, we gotta take a closer look at what's going on here. So this is an isosceles right, or sorry, not an isosceles right. It's an isosceles trapezoid. Let me zoom in on this a little bit. Hold on a second. Okay, so if we look at this trapezoid right here, it's isosceles because both of these sides are equal. So we got 5 and 5. And now I need to find this height. Okay. Actually, let's wait on that because we don't need to do that for the perimeter. We'll do that when we get to the area. Okay, so for the perimeter, you need to find these missing sides. So our scale factor is 8. So let's multiply all of our sides by 8. So 5 times 8, that's going to be 40 again. And then 40 for this side. And then 8 times 13, that is 104. So those are our dimensions there. Now you just want to add up your sides. So 5 plus 5 plus 5 is 15. Plus 13 is 28. Okay, and that's for the small ones, put that on the bottom. And then for the large one, 40 plus 40 plus 40 plus 104, that's a total of 224. Okay, and then you want to divide those. So 224 divided by 28, that is 8. If you type that in your calculator, you get 8. So again, it's proving to be consistent that our scale factor is the same as the scale factor of your perimeters, or your perimeter ratio, you could call it. Okay, next one, areas. Now this is where we have to find our height. You need to know the height of your trapezoids to find the area. Okay, because if you remember the area for a trapezoid, area is 1/2 of your height times base 1 plus base 2. Okay, that's your formula. So we have to know the height in order to find our area. Okay, so what we can do with this, since it's isosceles, we know that if we were to draw another height over here, that these distances would be the same, right? So if we think about what that total distance is, 13 minus 5 is going to be 8. So these two missing pieces together would add up to 8, and they're the same. So that means this little piece right here has to be 4. And now we can do the Pythagorean theorem. So if I draw that right triangle off to the side here, We've got 4 at the bottom, we've got 5 here. You can do Pythagorean theorem, or hopefully you guys are recognizing this is a 3, 4, 5 right triangle. So this is going to be 3. Okay, so that height there is 3. And now you can just use your scale factor to get this height 8 times as big, which is going to be 24. All right, so now we're going to use these numbers, finding our areas. So let's just plug those numbers into our area formula. So let's do the small trapezoid first. So area is going to be 1/2. It's going to be 1/2 of your height, which is 3, times base 1 plus base 2, so 5 plus 13. Okay, type that in your calculators, see what you get, or you can try to do it in your head. 5 plus 13 is 18. Half of 18 is 9. 9 times 3 is 27. Okay, next one. So that was our small area. Then our large area is going to be 1/2 of the height, which is 24, times base 1 plus base 2, so 40 plus 104. Okay, so I wouldn't do that one in your head. Just type that in your calculator. Okay, and you get 1,728 is what you should have for the area. Okay, now if you divide these numbers, if you take a guess, think about your scale factor. What should your area ratio be? Should be your scale factor squared. So it should be 64. Let's double check and make sure that works. So 1,728 divided by 27. And that gives us 64. So it's all working out. Okay, so it works out. We get 64. All right. Okay, almost done with today's lesson. This one, number 80, I'm just going to talk about this one real quick because I don't love this problem. But it says here, while Jessie examines the two figures at right, she wonders if they are similar. So decide with your team if there's enough information to determine if the shapes are similar. Justify your conclusion. So if we look at these two shapes, we can see that we've got 7 and 21. So that's 3 times as big. So that would be our scale factor, right? And then it gives us the areas, 40 and 360. Well, looking at the areas, that would be 9 times as big. 40 times 9 would be 360. So if we look at the scale factor compared to our area ratio, that makes sense. If we take our scale factor squared, 3 squared does give us 9. Does that guarantee that the two figures are similar? And the answer there is no. So I don't love this problem because they try to trick you with that. So are the two figures similar? Not necessarily. Okay, they are not necessarily similar. So even though your scale factor is 3 and your area ratio is 9, it does not guarantee that the shapes are going to be similar, because you could maneuver some of these sides to be different. I could change this side to go out maybe a bit further, and then change the corners a bit. Okay, and I would still get an area of 360, but these two sides would have a scale factor of 3. Okay, it doesn't guarantee that they're the same shape, is all that they're trying to show you there. Okay, all right, last problem. I want you guys to go ahead and pause this one here, okay, and read through the problem in your book and go ahead and answer this question. Okay, should take around 2 minutes. All right, here we go. So we want to find the perimeter of the enlargement. Okay, so we got this space to show our work off to the side here. Well, first of all, it says the area of the enlargement is 900 and the original area was 100. So first thing I'm going to do is I'm going to find the area ratio. If we take 900 divided by 100, let me zoom in a bit here. 900 divided by 100 is 9, so that's our area ratio. So that means that our scale factor is our area ratio, the square root of the area ratio, going backwards. So we get 3. Okay, so our scale factor is 3. So that means that our enlargement is 3 times as big as this. So we would take all of these side lengths and we would multiply it by 3. Okay, so if we can find and we're trying to find the perimeter. So if we find the perimeter of our original, the new one is going to be 3 times as big. Because remember, your perimeter scale factor is the same as your scale factor. They should match up. So we're going to use that 3 to help us out. So if we find the perimeter, we're going to take 3 times this original perimeter. So 3 times, add up all these numbers. So you've got 13 plus 4 plus 8 plus 4 plus 5 plus 10. This is our perimeter here, and we're going to take that times 3. So if you add those all up, you get 44, and 3 times 44, that's going to give you 132. So the perimeter of your enlargement should be 132. All right, good work, guys. Remember that homework assignment from yesterday. If you're not done with that, work on that for the rest of class today. That is due on Monday. Okay. All right.